In this video, we're going to talk about section 6.7, complex numbers. So, up until now, we haven't had a negative under a square root, but now we can. So, if there is a negative under the square root, we are going to just take the square root of the number and then put an I next to it. Alright, so the square root of negative 9 is 3i. Now they want us to find each of the following. I to the 0. I to the 0 is actually 1, because anything to the 0 power except for 0 is 1. Then I is just I. I squared is actually a negative 1. I to the third is a negative I. These are just definitions sort of that I would recommend that you memorize. But then when we get back to I to the fourth, this is 1 again. I to the fifth is I to the sixth is negative 1, and I to the seventh is negative I. And then when we're back to I to the eighth, that's 1. I to the ninth is I to the 10th is negative I, and I to the 11th is negative 1. Sorry, I can't read my own handwriting. Negative 1. And then we have I to the 11th is negative I. Now they want us to go all the way to 200. Now if you look at this, see these numbers here that are the exponent 0, 4, 8. If the exponent is a multiple of 4, like meaning that 4 goes into it evenly, then the answer is going to be 1. So I know that 200 divided by 4 is 50, or that 4 evenly goes into 200. So I know that I to the 200 must be 1. And I to the 201 must be I. And I to the 202 must be negative 1. And I to the 203 must be negative I. But then they want to know I to the 277. That one's a little bit difficult because I have 277 divided by 4. And so that is going to be, and we might want to do a little calculation here. Alright, so that is 69 with a remainder of 1. Alright, or 69.25, or 69 and a fourth. Now, if the remainder is 1, then we know that this is going to be I to the first power. So that means that this is I to 277 is I. Or you could have just worked backward and realized that 276 is a multiple of 4, and that's 1. And then the next one would have been I, and the next one would have been negative 1, and the next one after that would have been negative I. Alright, I hope that you enjoyed all of this, because I certainly did. Alright, so now let's look at the next little section here. So to simplify imaginary numbers, we'll use the same rules that we have used before. Alright, so pretty much you have a real part and an imaginary part. So the real part is this part that does not have an I multiplied by it, and then the other part is the imaginary part. Alright, so we're going to determine whether each of these pairs of complex numbers is equal. So 4 minus 7i and negative 4i squared plus 7i to the third. Now, just as a reminder of what we talked about just a second ago, I squared is negative 1, and I to the third is negative I. So, let's simplify the negative 4i squared plus 7i to the third. That's negative 4 times negative 1 using those rules, then plus 7 times negative I. So, negative 4 times negative 1 is 4. And 7 times negative I is negative 7i. So kaboom! These are definitely equal, meaning that they are the same. Alright, again, if you ever have any questions, feel free to reach out and ask me about them. Let's try B. Alright, so we have square root of 4 plus square root of negative 4. Remember how I said at the beginning square root of negative 9 was 3i? So I'm going to do something similarly and say that the square root of 4 is 2 and the square root of negative 4 is 2i. And these are not equal because one of them is 2 plus 2i and the other one is 2 minus 2i. Alright, so I hope that everyone is enjoying this, especially you, Lynn. I hope that you are enjoying this, Lynn. Alright, perform the operations. Write all answers in A plus BI form. 5 plus 3i minus 6 minus 9i. So here I am going to make sure that I don't multiply, but that I see the subtraction sign there and I distribute it. So I have 5 plus 3i minus 6 plus 9i. Then combine the like term. 5 minus 6 is negative 1. And then 3 plus 9. I just treat this like any other variable. This will be 12i. I can do something similar for b. Distribute the negative. So I have negative 7 plus 9i plus 2 plus 8i. The negative 7 plus 2 is negative 5. The 9 plus 18 is 17. It's a great day when the answer is negative 5 plus 17i. Alright, now let's try another one. This doesn't have anything that needs to be distributed. I can actually just drop all of these parentheses unless I want to distribute the plus, but that's usually pretty silly to do that. Alright, now combine the like terms. Negative 9 plus 2 is negative 7. Then 1i minus 5i is negative 4i plus 7i is 3i. So negative 7 plus 3i. Kaboom! Alright. Again, if you have any questions about this, feel free to let me know. But we're going to try a little harder one now. So we have 8 plus 7i minus negative 7 minus square root of negative 64 plus 3 minus I. Well, just like, again, negative 9 under the square root gave me 3i, then I'm going to actually say that this square root of negative 64 is going to be 8i. And then I need to distribute where necessary. So I have 8 plus 7i plus 7 plus 8i plus 3 minus I. Now, combine the like terms. 8 plus 7 is 15 plus 3 is 18. Then 7 plus 8 is 15 minus 1i is 14i. So plus 14i. The excitement is real. Alright, so let's move on to something that might be a little bit more challenging, and this is just multiplying. There isn't really anything new here either, but let's go through a few examples. So in A, we have 8 minus the square root of negative 4, or that's also known as 8 minus 2i. And then 2 plus the square root of negative 9, that's also known as 2 plus 3i. Then use the FOIL method. 8 times 2 is 16. 8 times negative 3 is negative 24i. Negative 2i times 2 is negative 4i. And negative 2i times 3i is minus 6i squared. Now let's combine the like terms. So 16 minus 28i minus 6i squared. This is where it gets a little bit difficult. If you read the note at the top of the screen, it would have told you that I squared is negative 1, or reminded you of that, and of the fact that you need to substitute this in for this I squared down here. Yes, there's more. Alright, so we have 16 minus 28i minus 6 times negative 1, but that becomes a plus 6, and then 16 plus 6 is 22. So 22 minus 28i. Alright. Now, I know that I'm excited about this, but I can't see all of you, so I hope that you are. Alright, stand up for math. B. 1 minus 3i squared. Remember, I can't just distribute that exponent. I have to write this out twice, and then use the FOIL method. 1 times 1, 1 times negative 3i, negative 3i times 1, and negative 3i times negative 3i. Then combine the like terms. Hopefully you're seeing that this is very similar to what I was doing in the last problem. But then I have to replace this I squared by negative 1 again. So what do I have here? All different colors here. Alright. 1 minus 6i plus 9 times negative 1. That will give me 1 minus 6i minus 9, and then 1 minus 9 happens to be negative 8. Alright, I hope that this is going okay for everyone. If there are any concerns, please direct them to Lynn, or you can email me. That is fine as well. Alright, let's move on to C. So I'm going to move this down a little bit farther here. So we have I times a negative 3 minus 2i times a 1 minus 2i. So you can take care of this extra I on the outside any way you want, but I'm just going to distribute it in here. So I have negative 3i minus 2i squared. Remember, you only have to distribute that extra I to one of the sets of parentheses. Alright. Now, some of you will wonder right away what to do here. Well, I squared, remember, was negative 1. So I can replace this negative 1 right here. So what I actually have is negative 3i minus 2 times negative 1 times 1 minus 2i. Or negative 3i plus 2 times 1 minus 2i. Distribute, or FOIL method. Negative 3i plus 6i squared, then plus 2 times minus 4i. Then I have another two like terms to combine here. So I actually have, what is it, negative 7i plus 6i squared plus 2. I have another negative 1 to substitute in. Yes, the fun keeps on going, doesn't it? And then 6 times negative 1 is negative 6. And negative 6 plus 2 is actually negative 4. Now remember, I always want to write the I at the end. So I need to rewrite this so it's negative 4 minus 7i. Always write the number in front of the term with the I there. Alright. Now, if you thought that was difficult, you can see D just got worse. But it's not that bad. Just make sure that you distribute this negative inside the brackets first and bring everything else straight down. So we have 5 minus 2i minus 2i minus 1. Then simplify inside the brackets. 2i and 2i gives me 4i. And then 5 minus 1 gives me the 4. And now I can use the FOIL method again. 2 times 4 is 8. 2 times negative 4i is negative 8i. Negative 3i times 4 is negative 12i. And negative 3i times negative 4i is plus 12i squared. Then combine the like terms to get 8 minus 20i plus 12i squared. And as always, as we've been doing in all of these problems so far, we're going to substitute in that negative 1 for the I squared. So we actually have 8 minus 20i minus 12. And what is 8 minus 12? Len, did you say negative 4? Great work. So negative 4 minus 20i. Kaboom! Alright, so I hope this didn't seem as bad. Just don't get this negative here confused with multiplying. You need to distribute that negative first. Alright, let's move on to the next page. Now we're going to go through and do some multiplying and some dividing. Now, we don't want i's in the denominator. So, remember that I to the 0 was 1, I was I squared was negative I, and negative 1, and I to the third was negative I. So, what I have here is I have 1 over I to the third, or 1 over negative I, and the only way to get rid of the I in the denominator is to multiply by an I over I. So I have I over negative I squared, and I squared would be negative 1, so I have negative 1, so I over 1, which is I. Kaboom. Alright, so if you didn't like that, just remember we have to use a combination of these four right here to try to get the I out of the denominator. Alright, let's try B. 5i to the third over 2 times the square root of negative 4, which is 2i. Now, let's reduce that. I know that I to the third was negative I from over here. And 2 times 2 is 4, so I have 4i. The i's just cancel, so that's negative 5/4. Kaboom! Alright, so hopefully you didn't find that one as bad as it could have been. Alright, let's move on to C. Again, I'm going to try to remember these rules here. So, what did I have? I had I to the 0 was 1, I was I squared was negative 1, I to the third was negative I, and then I have an I to the 7th here, so I to the 4th was 1, I to the 5th was I to the 6th was negative 1, and I to the 7th was negative I. So I'm going to reduce the negative 4 over 6 here to get negative 2 over 3. But I know I to the 7th is negative I. So that actually is a positive 2 over 3i. And then just like I did in example A, I need to multiply by I over I to get 2i over 3i squared, so that the I squared can be changed to negative 1, and that eliminates most of my trouble here. It's negative 2i over 3. Alright, now, that was it for the easy ones. Actually, I'm kidding. D looks amazing. Alright, so if you remember how we got rid of the square roots in the denominator, we're going to do the same thing. Is that we're going to multiply by the conjugate, or in other words, the same thing but with the opposite signs here. Then, remember my A minus B, A plus B pattern was equal to A squared minus B squared. So in the denominator, I'm just going to have 3 squared minus a 2i squared. So think back to when we did square roots and how we did that. Now, in the denominator, I'm going to actually leave the numerator factor, but in the denominator, 3 squared is 9, and 2i squared is 4i squared. But I squared is negative 1. So this is 9 minus 4 times negative 1, which is actually 9 plus 4, which happens to be 13. And 26 over 13 is 2. Kaboom! Alright, so this all came out fairly nicely. There wasn't anything really to worry about, in my opinion. So, there we go. Alright, maybe you guys are worried. I don't know. I can't see the looks on your faces. I hope that is not a look of worry from you. Alright, let's try E. 4 over 3 plus square root of negative 1. Square root of negative 1 is just I, so this is 4 over 3 plus I. Then I'm going to do something very similar to the last problem, multiply by 3 minus I. So I have 4 times 3 minus I over 3 squared minus I squared. Remember the A plus B. A minus B is equal to A squared minus B squared. Then I'm going to replace the I squared with a negative 1, so minus a negative 1. And 9 minus a negative 1 is 9 plus 1, or 10. So 4 times 3 minus I over 10. And the 4 can reduce to 2/5, or 4 over 10 can reduce to 2/5 if you would like. You don't have to do that, but you can. Alright, F is literally the hardest problem I've seen in my entire life. It's really not that bad. Alright, see this minus sign here? We're going to do this the same as the previous problems, but make it into a plus. And then the numerator is actually the same now. Alright, so keep that in mind as well. But if I follow the same pattern, it's square root of 3 squared minus square root of 2I squared. Then we have to use FOIL in the numerator. So square root of 3 plus square root of 3 square root of 2I plus square root of 2 square root of 3I, and then plus square root of 2I square root of 2I. Alright, now I know 3 times 3 is 9, so square root of 9. 3 times 2 is 6, so square root of 6I. 2 times 3 is 6, square root of 6I. And 2 times 2 is 4, so square root of 4I squared. That's a plus. Alright, then square root of 3 squared is 3. And then square root of 2 squared is actually 2, so that's 2I squared. Then I can combine these like terms here. So I know square root of 9 is 3, and then we have plus 2 square root of 6I because there are 2 of the square root of 6i's, and then I have the square root of 4 is 2, and then I squared is negative 1. So I'll replace both of these I squareds at the same time. Then this is 3 minus 2 is 1, and 3 plus 2 is 5, and then I can split it up into two fractions, 1 over 5 plus 2 square root of 6 over 5I. Alright, again, this is one of the harder ones, so I highly encourage you to look over it again. Alright, let's look at another one. We have G. So G, this is just asking you to square this. So it's I over 3 plus 2I times I over 3 plus 2I. So if I square this, I have I squared. The denominator, use FOIL. So that's 9 plus 6I plus 6I plus 4I squared. I know again that I squared is negative 1, so negative 1 over 9 plus, I'm going to combine these to get 12I, and then plus 4 times negative 1, and 9 minus 4 is actually going to be 5, so 5 plus 12I, and then I have to multiply by the 5 minus 12I. That part is still here. So I have negative 1 times 5 minus 12I all over. Remember how we did this. A minus B, A plus B. So 5 squared minus 12I squared. Oof. This is a lot. It's not that bad. Come on. Okay. So 25 minus 144I squared. But since I squared is negative 1, I have 25 minus 144 times negative 1. Or if I add these together, I get 169. So negative 1 times 5 minus 12i over 169. Uh-oh, I'm out of room. So split this up into two fractions, negative 5 over 169, and then distribute this negative to get plus 12 over 169i. Please do that. Please break this up into two fractions at the end. Alright, the next one is actually the easiest problem, so I'll end on an easy note. If I want to find the absolute value of 6 minus 5i, I just take the square root of both of the numbers squared. The 6 squared and then the negative 5 squared. Alright, so that's the square root of 36 plus 25. And that ends up being 61, so that is just the square root of 61. I hope that you've all found that one a little bit easier as well. Alright, that is the end of section 6.1. If you have any questions, feel free to email me and ask.